everybody. Thanks so much for joining us. This is a celebration of International Women's Day, a few days late, and Women in 3D Printing, celebrating the achievements and accomplishments of amazing women in space and aerospace and 3D printing. So just want to introduce everybody who's on the call today. We have Christine from JPL NASA. We have Kayleigh from HRL. And we have Maryna from EOS.
Hi, everyone.
Hi, how are you guys?
Good.
Oh, great.
Great, great. So thank you so much again, you guys, for giving up your time. And we won't have like the in-depth panel discussion that we were going to have at the museum. So this is going to be a bit of a short version of that, but hopefully you can share some of your experiences and people can get to know who you guys are. What are the great things that you're doing in your amazing careers right now? Why you decided to set on your path of being scientists, engineers, and you know, helping people understand what's going on in an amazing world today, and the things that excite you and motivate you in this current environment of manufacturing, additive manufacturing, 3D printing, space, and aerospace. So maybe just because you're on the top of the gallery screen, we'll start with Christine. So what first made you interested in science and engineering? Why did you want to get involved?
Yeah, so I was raised in a family of engineers, and so I saw it from a really young age. But really, when I entered high school, I had two really formative opportunities. I was able to join my high school robotics team and learn that, like, oh, building a robot can be very simple or very complicated, and you can do really cool things with really basic tools. And I was also a Girl Scout, and I was able to take part in the Girl Scout sailing program. So I got exposed to like aerodynamics and how boats work. And so between the two of those things, that really made me want to become an engineer and be able to build systems that I thought were inspiring and beautiful.
That's great. That's fantastic. And Kayleigh, did you have a similar experience?
No, actually, I have kind of an alternative background. I actually went to art school and studied in ceramics. I have a BFA in ceramics. And after school, I got into just as a technician working at this small ceramic R&D company, where for like 7 years, I learned everything about ceramic 3D printing. So now I work at the labs as a development engineer, as the kind of lead ceramic 3D printing engineer. So yeah, very alternative background, but you know, I don't find that it prevents me from executing my job really well in any way. So yeah.
That's pretty cool. And Maryna, you're currently working for EOS, which we should say EOS is a sponsor of Women in 3D Printing. So thank you very much. But let's hear your story.
Happy to be. So it's difficult to say what exactly made me become an engineer as I am now. But looking back and thinking, like when I was growing up together with my sister, and when I was little, I was always interested about puzzles, about solving some, playing with Lego, playing with solving the tasks. And my sister would always like to play with dolls, dress them up, brush their hair. So, and also, like when I was growing up, I would ask lots of questions, of course, a lot of whys. But then on top of whys, I would also ask, how is it made? How is it made? How does it work? So I was already interested in how the things are made. And at school, when I was going to school, I would like physics. And after school, I would stay to learn more about physics and to learn more about how physics applies to daily life. Like, oh, what is this shoes? Why they have stronger friction or something, why those are almost sliding on the surface. So I was kind of interested how physics applies to life. And then when I went to school, I became the engineer, and I'm pretty happy with what I'm doing now.
That's great. So I think the overwhelming story with all of us here today is that we're driven a lot by curiosity.
Yeah,
So Christine, why don't you give us a couple of examples of how curiosity also fills your day and drives you towards doing the things that you do in your daily job?
Oh, wow. That's a broad question. Okay, let me think. So one cool task that I'm really interested in right now is I'm in the deployable structures group here at JPL. And so we build all sorts of structures that deploy, and that can be antennas or solar panels or whatever needs to go to space and get larger. And I'm really interested in how we can use additive manufacturing for deployable structures. And that's actually a really fun challenge because the parts that we 3D print now aren't at the scale that deployable structures are at. So we build structures that are meters long, and we 3D print things on the scale of centimeters at this point, at least for the most part. And so I'm really, like, curiosity has driven me to see, like, how can we leverage the design freedom that additive manufacturing gives us to create these very large structures that often have to have really specific pointing requirements or really accurate geometries. And so I'm working right now to figure out how we can use compliant mechanisms within deployable structures and leverage additive manufacturing. That's a lot of buzzwords. What that really is like, how do we use 3D printing to print things that bend and they can go to space and get larger and help us do cool science? So yeah, that's the really direct one, but.
Fantastic. And Kayleigh, I know that you're also working on 3D printing, but you do something quite special that I don't hear a lot about. So maybe you just want to tell us quickly what that all is about.
Yeah, so I think what you're getting at is the ceramic printing that we do here. So we basically use a polymer-derived ceramic that can convert into a ceramic in a pyrolysis cycle. So basically that's a polymer with a silica in the backbone, and then when all of the volatiles burn off in the pyrolysis cycle, the molecules have to rearrange and turn into this like silicon oxycarbide. So we do research here on how to reduce those oxygen levels and get just a pure crystalline silicon carbide from a polymer-derived ceramic. And then we do a series of toughening mechanisms with different particles or silicon carbide whiskers. The primary program that we're working this for is NASA Tipping Point program, so that we can 3D print a second stage satellite rocket launcher nozzle out of this silicon oxycarbide mixture. And that's for just 800-pound thrust. So think more like milk carton size, not something you can stand in size. And this is using a stereolithography process. So we found ways to make the polymer-derived ceramic UV curable instead of thermally curable like it usually is.
That's so cool.
Great to introduce you guys together.
Yeah, so if you need ceramic parts, Christine.
We do lots of optic benches here. And
okay.
I know, like, ceramics are often used for that. Anyway.
And Maryna, I know that EOS have both metal printers and polymer printers. So what are you working on right now?
So I'm currently working with the metal. And yes, I'm part of Additive Minds team. It's our applied engineering team. So we have our team for the polymers, for the metals, as well as consulting team. And all together, we would help the customers to develop the applications. And it's all about the curiosity, because the customers would come with us with the questions, how to build this part, how to make this part work for additive, because we used to do it with different process. But now we see how additive can help put the parts into space, make them lightweight. And now we would like to use what is already known about part performance, keep the performance, but to adjust it and make the parts suitable for additive. So there is lots of curiosity involved, how to make it work with the principles that we know, but how to apply those to make lattice build or to make the topology optimized structures to make them successful, reduce the supports to minimum so that we can minimize waste and make process even more sustainable. So I'm on the metal side, and EOS works with the powder bed process, meaning that the powder is loaded into the machine, and then the laser is used to melt the powder layer by layer. So there is lots of physics involved. I can keep learning my physics as much as I want. So very excited.
That's fantastic. And what I love about 3D printing is it's growing all the time. There are so many different techniques. There's different heat sources. There's different methods, different materials, metal powder, wire, all kinds of different things, polymers, ceramics now. People are 3D printing houses, habitats. They're printing biomedical implants. They're even 3D printing shoes. And so literally, and rocket parts. So I shouldn't forget that because I work with those every day. So really, it's very inspiring to be in a technology that also enables, you know, us to meet other women, which is amazing in this area, because typically if you think of engineering and, you know, maybe space exploration or rocket manufacturers, you don't get so many female role models. And it's really important to keep pushing that and to keep letting people see the amazing things that you guys are doing, that you're involved with, speaking to young people and kids, girls in STEM programs and all those kind of things. So who were people that inspired you? Maybe Christine, you wanna lead with that one?
Oh, geez. Come back to me. I'm gonna come back to me. Is that okay? Am I allowed to do that?
Yeah, you
Okay.
can take a pass and come back.
Okay.
What were your heroes or inspirations?
You know, I think it's maybe a series of mentors that I've had in my life and people that I've kind of met along the way, and really the material. I'm just so in love with ceramics as a material, and this moves from like me being 5 years old making mud pies in Oklahoma to like me being in college, you know, making sculptures, and then now using 3D printers to shape ceramics into, you know, engineering applications. I'm just so in love with the versatility of the material itself. And I just see 3D printing as another tool to get ceramics into a good shape. They're traditionally difficult to manufacture. You have very limited ways of working with it. And I've been so lucky along the way to just have really great mentors and people in my life to kind of help me learn as much as I possibly can about it without breaking everything along the way. With breaking most things and then learning how to fix them, honestly. So, yeah.
Story. And Maryna, were there any people who helped you? Maybe they were women, actually.
Oh, I will do bad if I don't mention the people who made the biggest influence or like grew me along the way, as there is lots of influences, but the one that I remember when I, especially like going back to my childhood, when I was growing up, my father would fix the cars, fix the vehicles, and I would always play around him, just play with my toys, play with my pieces of Lego or whatever. And I would watch him fixing the things and how the parts come together into assembly, and this drew my interest into the mechanical engineering eventually. So I think this was one of the influences that made the biggest footprint in my mind, and then now I'm a mechanical engineer. So.
Fantastic. And Christine, did you have time to think of
in
your life?
Thank you. I think from an early age, I was always really like, I was lucky enough to be exposed to lots of cool engineering applications. So I grew up in Houston and I got to go visit Johnson Space Center as a child. And so I got to see, oh, we can do that. You can build systems like that. And I got to, in high school, I got to meet people who build systems like that. So seeing like, being able to interact with engineers who are mentoring high school robotics teams showed me that there are people out there who do that sort of thing. So as I kind of grew older, I was able to have these incredible mentors in high school and in college who were building robots at NASA and building welding robots for the oil industry and building sailboats and all sorts of like various mentors who showed me the beginning steps of things and how these incredible spacecraft and sailboats and whatever were built. And I've always found that really inspiring.
That's amazing. You guys all have different stories. I just want to share with you really quickly my story. So actually, I was heavily influenced by Star Wars and Star Trek. And so I grew up in England, and we don't really have the history of having a really good space program, which is rather sad. But I saw Star Wars when I was 5, and I always wanted to be, not Princess Leia, I wanted to be Luke Skywalker because he had his own little X-Wing fighter. But I really loved Star Trek because it was the idea of lots of people coming together from diverse background. You had Mr. Spock, who was like an alien, and you had all these other people, and they brought all the great knowledge and team working and always come together to make, you know, a positive future. And I saw that and I was like, I want to be like those guys. I want to be going to the stars. Of course, I didn't think I would ever do it, but now I'm working in this country, and I've got the chance to work on space-related programs. So I'm very excited I'm very grateful for that. And one of the things I'm really excited about is that 3D printing is, I hate to say it again, but it really is the technology that's letting all these people, especially new space people, come into the world. So, you know, are you feeling the effects of that? Do you interact with lots of people in the space and aerospace community? Obviously, you're at JPL, so that's an obvious one. But Maryna, some of your customers are in the aerospace or space supply chain. And Kayleigh, obviously, you do a lot of work for people in the aerospace and commercial as well, So how do you guys see all that supply chain working out, and what's your interaction with them? Maybe Maryna, you want to kick us off?
So recently we did the project. We won CAN agreement with NASA. So I had the opportunity to work together with NASA to develop the ultra fine lattice. And this lattice can be used in the different ways. The one of them was in the propulsion technology to help to promote catalytic reaction. With additive, you can, by modifying parameters, you can also modify the way the structure is performing, whether it's very stiff or it's very compliant, and if it has thin walls or reduced wall thickness. So it was a very exciting project, and I had a chance to contribute at the Aerospace. This was my very recent experience.
That's great. And Kayleigh, can you share any anecdotes or stories about your brush with space or aerospace and the people you're kind of working with at the moment?
Yeah, and I think maybe I can relate with Christine on this, but I actually have a part that I made on the Curiosity rover. And this was something I did at my previous job, so it wasn't made at HRL, but they basically contracted us to make these little small, like NASA heater housings. It's basically just a small heating oven. It's about 1 inch, 1.5 inches tall, and it had 52 20-micron holes in it and a hollow center. There's no way you can make this part without 3D printing it, just because the holes were so small and so close together. So we made parts for them, and it's basically it's on the SAM module, and you know, he collects a little soil sample and puts it in there, and then flash heats it, and the sample analyzes all of the gases that come off of it. So in 2013, don't quote these dates, by the way, I think this should be right. I think in 2013, it discovered chemically bound water on Mars. And then in 2018, it discovered organic compounds on Mars. And so it was really cool to have touched that thing that made these discoveries. And they actually had some interesting results that they contacted us to make more parts so that they could repeat those tests on Earth to see if what they were seeing was real or not. So that was a pretty cool thing to be a part of.
That's awesome. I didn't realize there were 3D printed parts on Curiosity Rover.
Yeah.
I want more information about that. I don't know why I didn't know that. I feel embarrassed now.
There's at least one ceramic.
Yeah.
Well, at least 5, because I think they have 5 of them up there in case one broke. Like,
that might have been the first 3D printed part on a Mars rover, I think.
what?
Yeah. Don't quote me on that either, but I have suspicions.
I call it my Mars trash because no one's going to clean it up. Maybe
That's
one
fair.
day. Yeah.
Can you remind me of the question? It was, how does...
What you do relates to space, obviously.
Oh yeah, so my job is kind of all over the place as it relates to space. Right now my main task is to help build a spacecraft called SWOT. So SWOT stands for Surface Water Ocean Topography, and it's a climate change tracking satellite, or an Earth science satellite, that will do the first global survey of Earth's surface water. So it'll kind of continuously track what the water level is all around Earth, using all sorts of cool radar science. And as an engineer, that's probably the extent that I am qualified to describe the science that this mission does. But the other side of my job is to help develop various technologies for the next generation of spacecraft. So when I'm talking about using additive manufacturing for deployable structures, we're doing early technology development. And oftentimes that means collaborating with people like HRL and EOS and Morph3D to learn how they're doing things and how we can apply it to the missions that we're developing. So we have a whole bunch of EOS printers here at JPL. Yeah.
That's fantastic. So it's such a shame that Lindsay and Hamna are not able to make the call, because they would have completed the rest of the conversation there. But anyway,
The whole 3D printing industry in one thing.
very good. Okay, so that is a fantastic snapshot, you guys, of a glimpse into your lives and what you do, the sort of thing that gets you inspired, why you get up and go to work every day, and keep doing what you're doing, because it's amazing. So just want to leave with one final thought from each of you, because International Women's Day is just one day of the year, but we are women and we are engineers, researchers, scientists, builders, leaders. What do you think of, you know, being a woman in this field? What are your general thoughts? Do you feel pretty happy that you're where you are? You're pretty satisfied? Are you thankful that you are where you are? You're excited about the kind of things you do? And what's the message that you want to give to younger people to inspire them to follow in your footsteps?
I'll go first. So have a few thoughts. I'm super thankful for the women who paved the way for me. There are plenty of professors that I looked up to in college, and women at JPL and in the aerospace industry in general that I've been able to look up to and say, oh, that's awesome. Women are still definitely in the aerospace industry, especially in the technical community. However, I'm excited that 3D printing in some ways democratizes engineering, and that you can get started 3D printing with a $200 printer now, and that the things that you learn with a very easy 3D printer or a very cheap printer can apply all the way up to like the world's most beautiful 3D printing metal machines. And so I'm excited to see that democratization allow more women to enter the aerospace workforce. So yeah.
And Kayleigh, what kind of thoughts do you have on that closing subject?
Yeah, I'm having such an alternative background. I'm really proud of the path I've taken. And, you know, I was always really good at science and all of that stuff in college, but I just knew that I needed to go to art school. And then I sort of found my way back into science. So I guess I guess what I really want young people to know is to not be afraid to do something that you're very passionate about, because passion is what got me here, and it's what's going to keep me going along this path.
Fantastic. And Maryna, what are your closing thoughts on this subject?
I totally support and agree with Christine and Kayleigh, and it's not one person job, and I'm very passionate about what I'm doing. I'm also very happy where I am, and I'm grateful for so many opportunities that I have as a mechanical engineer, that I have as engineer, applications engineer in additive manufacturing, that I have by being part of EOS and part of Additive Minds team, because the Additive Minds team is very diverse. We have both men and women from the different cultural backgrounds, and we work well together. We complement and make one integrated team. So, and I'm very proud to be where I am because I have lots of opportunities to share my expertise. Like Christine, you mentioned you've been in the Girl Scouts, and I've recently also went to Girl Scouts and shared with them some ideas about additive, had their feedback, encouraged them to try, and definitely told them what they're doing is the 100% right thing, to understand what is involved in the different areas, like what is in robotics, what is in the additive manufacturing, what is in the economics. Anything you can learn, just try to understand, and learn and understand what you like to do, where is your passion, and then pursue it and smile and be happy, put efforts to anything you do. And that's my idea.
Well, that sounds great. It's fantastic. And yeah, like I said, International Women's Day is one day of the year, but actually as women, we live our lives every single day. So we have to keep doing what we're doing every day. So just want to say thank you so much to you guys for sharing the time. I'm so sorry that our event at the museum got canceled because of the state of California and the mayor declaring a state of emergency and whatever. But we'll know more in the next 2 weeks if we have to isolate ourselves or go on to global lockdown. But anyway, even if we do, we'll be able to play this video back and get inspiration from that.
From your computer under global lockdown.
Well, thanks for organizing.
Thank you. This is a great idea.
Digital.
Yeah, and we'll get together sometime later in the year when we know when we can have an actual face-to-face event.
Yeah.
Yeah.
Sounds great.
Great. Nice to speak to you guys. Have a great day. Bye.
Nice talking.
Bye.
Bye, everyone. Thank you.